Bonsuelo Mathletes, video number 3 in just the first section of chapter 2. This is what makes life great. Okay, what we're going to talk about today is something called functions. And a lot of this at the beginning is going to be definitions, for which can kind of get tedious, for which I apologize, but let's just get into it, and then maybe it'll go a little quicker if we don't just ponder life as we're doing this. Okay, some definitions. A relation. A relation is a set of XY pairs. It can look like a list of XY points. In other words, I'm going to write some stuff down here as usual. Like I can put a 3, 2, 9, 7, 13, 4. That's a list of XY points. It can look like an equation. Y equals 5x squared plus 7x. You don't need to write these down. Or it can look like a graph. Okay? Something like that. Okay. Those are just examples of what I mean by those, which hopefully is pretty obvious. Okay. Now, the domain. And I'll explain this in a little more detail, but the domain is the set of all values of the independent variable. The range is the set of all values of the dependent variable. Now, again, I'm going to write some stuff down. I don't know that you really need to write this down as much as listen. Okay, think about this. Let's say I asked you to graph y equals 7x squared plus 4. Okay, how would I, if I asked you to graph that, how would you graph it? Hopefully, you'd make an XY table. Okay. Well, when you make an XY table, what numbers do you just pick off the top of your head? Like, do you pick the X's or do you pick the Y's? And even though, it's possible to pick X's and plug in and find Y, or you can plug in Y's and find X's, the most common method of operation is to pick X's. So we start with 0 for X, and we go 7 times 0 squared multiplied by 7 plus 4 is 4. Then you plug in 1, and you go 1 squared is 1 times 7. 7 plus 4 is 11. Then you plug -1. Do the same, blah, 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 blah. Okay. Well, think about what the words independent and dependent mean. And which is the independent variable here? Which is the dependent variable? Well, take a second, pause the video and think about it for a second, but I'm going to, again, I don't really give you much time to I don't put the pause in the video itself, so I'm leaving you to pause and think about it. But basically what it is X is independent. We can pick anything we want. We can pick 0, 1, -1. We can pick 9/4. We can pick 13.7. Now, we might not pick those, but we can basically pick anything we want. Now, once I do that, can I pick anything I want for the Y? So like here, when I picked 0 for X, could I just, I don't know, I want Y to be 942. No, that's not correct. Because once you pick X, you have to calculate Y, okay? So the value of Y depends on what you pick for X. And X, you can pretty much pick anything, although certainly you don't want to just pick random weird numbers. You kind of want to do it methodically, but still it's independent other than it's just comes out of your brain. Okay, so when we're talking about the set of all values of the independent variable, we're talking about values of X. And when we're talking about the range, the values of the dependent variable, we're talking about values of Y. So any one of these things could kind of be synonymous. Domain, independent variables, and X. Or range, dependent variable, and y. Now, there's one more phrase I could use, and that is, what do we do with x once we pick it? We put it into the equation. It is the input. Be good if I know how to spell input. It's not that complex of a word. You'd think I'd be able to spell it, but I can't. Okay? And of course, then what's range? It's whatever the equation gives us out. So it's the output. So I could use any one of these four phrases and it all means the same thing. Domain, independent variable, x, or input. Or I could use any of these four things and mean the same thing. Range, dependent variable, y, or output. Okay, fine. That all leads up to the main definition we're interested in here. Well, I'm interested in telling you. I don't know if you're that interested in learning about it, but anyway, and that is what a function is. A function is a relation. So again, what's a relation? It's a set of xy pairs. It can look like xy points, an equation, or a graph. Okay? It's a relation where each value in the domain leads to exactly one value in the range. So in other words, what it's saying is one domain value leads, so I'm going to express this a little bit differently. If I could write properly, I would be able to express it a little differently. Exactly one domain value leads to exactly one range value. Now, how else could I express this? Exactly one x value leads to exactly one y value, or exactly one value of the independent variable leads to exactly one value of the dependent variable. Or you could say exactly one input leads to exactly one output. Okay, so what's that look like? So what are some examples like of domain range and whether something's a function or not? Okay, so here I'm going to start with xy pairs. Remember, I can be looking at xy pairs, equations, or graphs. Equations we're going to kind of do another day, but equations we're going to do later. But we're going to start with xy pairs. Not that they're the most valuable thing, but I think it's easier to explain definitions using these. Okay, so state the domain, state the range, and tell if it's a function. Okay, so what's the domain here? The domain is 2 and 13. Okay, we don't need to list the 2 twice. Okay, what's the range? The range is 4, 7, and 8. Notice I'm not necessarily listing them in the order in which they appear in the original statement there. I'm just listing them in order. So that doesn't mean the 2 goes with the 4 and the 13 goes with the 7 or anything like that. There's no order implied here. Okay, the 2 goes with the 7, the 13 goes with the 4, the 2 goes with the 8. I'm not changing that. Okay, now, is this a function? Well, here's the idea. When x is 2, what's y? Okay, you'd say, well, when x is 2, y is 7. Could an x value of 2 ever give me something other than 7? Yes, because notice here on the end, it could give me an 8. So if I hand you an x value of 2, do you hand me back exactly 1 y, or could you hand me back more than 1 y? And since you could hand me back either 7 or 8, therefore exactly one value of x, 2, leads to more than one value of y. Therefore, it is not a function. Now you could say, well, what about the 13 and the 4? Yeah, but it has to work for everything in the whole problem. Okay? Now let's take a look at the domain for the part B. That would be 3, 10, and 15. Let's look for the range. And that would be 9 and 10. Okay, is this thing a function? Well, when x is 3, what's y? 9. Is it ever anything else? No. When x is 10, what's y? 12. Is it ever anything else? No. When x is 15, what's y? 9. Is it ever anything else? No. Notice it's domain to range. The other way around doesn't matter. But if I hand you a 3, you can only hand me a 9 back. If I hand you a 10, you can only hand me a 12 back. If I hand you a 15, you can only hand me a 9 back. For each domain that I would give you, there's exactly one range. So this is a function. Okay. Now, the next thing I'm going to tell you, so I'm just going to kind of like leave it with XY pairs for right now. The next thing I'm going to tell you is just notation. It doesn't tell you how to do anything. It's just a matter of how to read something. So if a relation is also a function, then the dependent variable, in other words, y, may be written, that's read f of x. It's not f times x, it's read f of x. So that's the way you should read it. And by the way, does it have to be an f? No. It can be like g of x, it can be h of x, whatever. Okay? Now, y equals x squared is a function. I'm just telling you that. You don't have to worry about, like, how does Mr. LeBlanc know that? He must be a genius. Just telling it to you. Okay, so y equals x squared is a function. So it may be written f of x equals x squared. Those two equations are the exact same thing. This and this are the exact same thing. Okay? Now, what is the purpose of doing that? One, it tells you something that you don't know otherwise, and two, there's something else I'll get to in a little bit. But if I asked you, is y equals x squared a function, you may or may not know that. You'd have to think about it. You'd have to figure out whether it is or not. But if I tell you f of x equals x squared, is that a function? Yeah, it's a function because it says, I am a function. As soon as you write f of x, it means this thing's a function. Okay? So it tells you that something's a function, and there's something else which we'll get to in a little bit. Okay. Now, let's say I give you the problem given y equals x squared, find the value of y when x equals 3. So what would you do? You'd say y equals 3 squared, you'd substitute 3 for x, and then you'd get 9. So the value of y is 9 when x is 3. Okay, well, what's this problem? Given g of x equals x squared, find g of 3. Now, this is what that g of 3 means. Okay? Now, you read it g of 3, but what it means is this, the value of y when x equals 3. Okay? That thing that you read, g of 3, it means all of that. Okay? So if I write, you don't need, I'm going to write some stuff down. You don't need to write it down. If I write h of 7, it means the value of y when x is 7. If I write, k of 4, it means the value of y when x is 4. Sorry, I might have made a mistake in the thing I just said before. This one would be the value of y when x is 4. And the one I said before about the h of 7, I apologize, I might have said something wrong. This is the value of y when x is 7. Okay, I'm pretty sure that's what I said, but I'm not sure, so I just want to make sure I'm clear on that. This would be the value of y. That's all it ever is, okay? So That's all it ever means. It doesn't mean anything more or less than that. That's what it means. So how would you do this problem? Well, notice the problem right above it. Given y equals x squared, find the value of y when x equals 3. Fine, we can do that, no problem. This says given g of x equals x squared, find what? The value of y when x equals 3. Now you read it, g of 3, but what it means is the value of y when x is 3. So what do? The same thing. There's going to be one little difference, though. I'm going to write it down twice and just watch. Okay, the typical way to do this would be this. G of 3 equals 3 squared, and the g of 3 equals 9. Now, I'm going to suggest you not do that for the following reason. There are a couple of reasons, but the most obvious one is a lot of people think, oh, now I have to get g by itself, so I have to divide by 3. No, that is not g times 3. That whole thing, g of 3, means y equals 9 when x equals 3. That's what the g of 3 equals 9 means. The value of y is 9 when x is 3. Okay? So what can you do to maybe avoid that? What I would recommend you do is this. The g of 3 is 3 squared, which is 9. It still means g of 3 is 9. The value of y when x equals 3 is 9. But you don't have it written like this. And you, particularly at the beginning, you might make the mistake of trying to divide by 3. Okay, so I'm going to get rid of that. I'm not saying it's wrong. It's perfectly correct to write it that way. I'm just saying it leads to errors. That's all, particularly at the beginning. Okay, so I would recommend you do it this way, where I've written it without using an equation. Okay, now, if you understand what this means, this should not cause you too much grief. So what I'm going to ask you to do is pause the video, and given that graph of k, okay, find the k of 1. Now, ask yourself, what does he mean find the k of 1? Well, go back to what function notation means. Okay? Now, pause the video and do it. Okay, I'm gonna actually do it here, but I assume you've paused it and tried. Okay, what am I asking you to find? This is find the value of y when x is 1. Now, I want to point out something. First of all, this is very important for you to understand. Where's the graph here? Okay, is the graph like all of this stuff, you know, all this? No, this is not all the graph. Okay? The graph, and again, don't write this down. The graph is this thing. The graph is this thing that's drawn on the grid. That's the graph. Okay? The rest of it is it can be called the rectangular Cartesian coordinate, the Cartesian plane, the rectangular coordinate plane. But this thing, which I'm going to kind of draw a little heavier line on it and then erase it, this thing, okay, that's the graph. And it's the only part that's the graph. The rest of it is just what gives the graph meaning. It's the Cartesian coordinate plane, the rectangular coordinate plane. It's got a bunch of names. But the thing that I just wrote over, that's the graph, okay? So for instance, okay, let me show you something. Is this point that I just put part of the graph? No, it's not. Is this part of the graph? No. Is this part of the graph? No. Is this part of the graph? Yes, because it's on the graph, okay? Is this part of the graph? No. Is this part of the graph? No. Is this part of the graph? Yes. Of the, 6 dots I've got there, only 2 of them are on the graph. And I know this may seem obvious, but a lot of people don't really get this. So you have to understand, wherever you're going to get the answer from, it's got to come from the graph. It doesn't come from the Cartesian coordinate plane per se. It's got to come from the graph, which is on the Cartesian coordinate plane. Okay, so what does k of 1 mean? K of 1 means find the value of y when x equals 1. What I'm saying is somewhere on this graph, there is a point and its x coordinate is 1. Well, what's its y coordinate? Well, don't look here because that's not on the graph. Yeah, the x coordinate, that's 1, but that's not the graph. Okay, so somewhere on here is a point. All of these things that I'm sketching on here, they all have an x coordinate of 1, but only one of them's on the graph. Okay? So, which one is it? Let me get rid of these. It's this one right here. That's a point on the graph that has an x coordinate of 1. And what's its y coordinate? 3. The k of 1 is 3. Okay? Now, I'm going to erase that, but you may need to go back and listen to that again. Okay? Because I have to do the other ones. Okay. So let's look at the next one, the k of negative 1. Okay, somewhere on the graph is a point that has a coordinate of negative 1. Where is it? Oop, what did I just do? By the way, try and figure it out for yourself first, okay? But it's right there. And the k of negative 1 is negative 5. Okay? And I'm erasing these as I'm going, so you may have to back up the video a little bit. The k of 5. 1. And what's the value of y when x is 5? So I'm going to go up to an x value of 5. 1, 2, 3, 4, 5. And what's the corresponding point on this graph that has an x value of 5 right there? And its y coordinate is negative 5. Okay, what's the next one? K of 1.5. So I'm going to go out to 1.5, and I'm going to go up and right about there. So, just approximately, that's about the best I can do. So what does it look like? I don't know, it looks like about 3.5. Okay? Now, and again, if you have questions on this, ask me. Ask me, because we're going to keep doing this time and time again all year, so you got to get it down now. Okay, so what am I asking here? I'm kind of asking for the opposite. Before I was giving you x and saying, tell me y. Now it says, tell me x when what? Y equals 4. That's what k of x means, y. So what value of x will give a y value equal to 4? So I'm going to go back to the graph, and I'm going to go up to the y value of 4. And all of these points have a y value of 4, but they're not all on the graph. Okay? So let me get rid of them. Okay, so what one is on the graph? That one right there. And what's its corresponding x coordinate? 2. What's the next one? What value of x will give y equal to 3? Now notice here, there are 2 of them. There's one there and one there. So what are the x coordinates for those 1 and 3? There are 2 answers for this. Okay? And then what value of x will give a y value of 2? Right there and right there. So roughly, what does this look like? I don't know, about 0.8 and maybe 3.2. By the way, is this a function? Well, you don't even have to think about it unless I've lied to you or made a mistake. I've told you it's a function. But, okay, what happened here? Each x gave me exactly 1 y. Okay? But what about this? Well, it doesn't matter. What about the second part? It doesn't matter because a function is always x to y, okay? These are y to x, and that doesn't matter, okay? All right. Again, I know we go through this pretty quickly, but if you have questions, listen to it again, pause it, think about it, and then ask me a question. Okay, let's take a look at these. This is something called a piecewise function. This is one graph. It's not two graphs, okay? It's one graph. It's just got several parts to it. It's got on the left here kind of this flat line, and then a line going down, then this curved thing, and then the line going off there to the right. But it's one function. It's one graph. Okay, so what's the f of 0? The f of 0 says what's the value of y when x is 0? And there's a point right there, which is at a y value of 1. Okay, what's the f of 1? Well, at an x value of 1, we have a point right there, and the corresponding y value is 0. By the way, that doesn't always work, that, the 1x giving the y. If you switch the y and the x, that's maybe misleading to you, but. Okay, how about the f of negative 2? Okay, here, I'm going to draw kind of a dotted line, but it's not part of the... Okay, we go up here at negative 2, the corresponding y value is positive 2. Okay, now here you got to follow me. Here you got to stick with me. The f of 2. Okay, so we've got an x value of 2 here. Is that a point on the graph? No. Why? Because it's blank. It's kind of like saying this. Let me show you something. I'm going to start drawing some x's on the screen. Don't you do it. Okay. Is that on the graph? No, it's not on the graph. It's on the coordinate plane. It's not on the graph. Where's the graph? The graph is where the ink is, drawn on the coordinate plane, right? Well, there's no ink over here where that x is. How about this? No, that's not a point on the graph because there's no ink there. Okay, well, how about this then? At an x value of 2, is this a point on the graph? No. Why? Because there's no ink there. It's an open circle. It's like a hole. So where is there a point? Well, up here, there is a ink. And it's got a y value of 3. And if you came up with two answers here, both negative 1 and 3, there's something wrong. Because I've told you this is a function. So each value for x gives us exactly one value for y. So we can't get two values. Okay. Let's go for one more problem. Okay. Find the g of negative, again, this is one graph. It's got several parts, but it's one graph. Find the g of negative 3. Let's go over to negative 3. And there's the point on the graph that's got an x value of negative 3, and that's down at negative 1. Okay, the g of negative 2. Okay, I'm going to draw a dashed line here again. Okay, I'm at an x value of negative 2 going down. That's not a point on the graph, but that is. So it's got a y value of negative 2. Okay, not negative 1 and negative 2, just negative 2. Okay, the g of 0 is there, so it's got a y value of 2, and the g of 2 is there, so it's got a y value of 0. All right, so what we've looked at today is, first of all, a lot of definitions. Okay, what's a relation, what's domain, what's range, and what makes something a function. Then after that, we took a look at function notation, and it's very important you understand what this means. See, this does not mean, this find g of 3 does not mean plug in 3 for x. It means find the value of y when x is 3. Now, yes, in this particular problem, we plugged in 3 for x because that's the way you deal with an equation. But like on these graphs, there's like find the k of 1. There's no place to plug in a 1. There's nothing to plug into. It doesn't mean plug 1 in for x. What it means is, tell me the value of y, that there's some point on this graph that's got an x value of 1, what's its corresponding y value? And it's very important that you understand that idea. And if you have a question on it, please ask me. So, hopefully we're back in school by the time you listen to this video. I'm making it while we're still out of school, but, if we're there, just ask me right away, okay? And even if we're not, ask me. Just find a way to ask me if you have a problem with this. Okay, have a great day, everybody. I hope you enjoyed this lesson. I guess that's the word I can use, enjoyed this lesson. In section 2.1, we've even got 2 more to go. They're not quite as long as this, but just something to look forward to. Bonsuelo, everybody.